Hello everyone, my name is Vlad Stoyanovsky and today we will be discussing business analytics in higher education. First, what is business analytics from the IBM point of view? It's not just about bringing data together, it's not just about getting insight from your data, and it's definitely not just about business intelligence. At IBM, we believe that business analytics is about turning information into better outcomes. For business leaders to be able to make smarter decisions that lead into better outcomes, they need answers to three fundamental questions, and that is, how are we doing, why we're doing what we're doing, and what should we be doing? Getting answers to these questions is important across all departments and all industries and all verticals, including higher education. With the higher education customers that we're working, we're seeing a large explosion of data and data sources. However, finding the right information is challenging. That's one of the first things that we address with business analytics. And using reports and dashboards, we'll address that first challenge of understanding how we're doing in certain areas. So as a university administrator, I may discover a trend that concerns me, and that is that second-term enrollees are dropping out at an alarming rate. In other words, freshmen that are coming in the first term are not staying and enrolling in the second term. So that's a trend that I may be able to discern by looking at a report and a dashboard, and it's how we begin to answer the question of how we're doing. In addition to reports and dashboards, other capabilities that fall into this particular area are proactive alerts, reactive alerts, being able to access these reports and dashboards and alerts on a variety of devices, including a desktop browser, a mobile device, Microsoft Office, email, etc. It's typically the business intelligence functionality that most people think of. The second capability that I'll be discussing is scorecards and key performance indicators. These are helpful because now we can start seeing not only how we're doing against trends, but we can also see how we're doing against benchmarks that are being set, targets, thresholds, etc. In addition to that, we can start to look at leading and lagging indicators. So we may find that in particular majors, the student to faculty ratio is higher than what we have targeted, and it's those particular majors that are seeing a larger dropout rate from the first to the second term. So now we begin to answer the question of not only how we're doing, but we also start to get a glimpse into why we're doing what we're doing. The third capability on this spectrum is ad hoc analysis. So as a data analyst, as a university administrator, I can start to look at this data by various different angles or dimensions. So I may start to look at the students that are not enrolling or that I'm not retaining from first to second term by various demographic characteristics. I may start to look at them by ethnicity, for example, by their GPA, by whether they live on campus, by whether they are on financial aid. And one of the things that I may discover here is, for instance, that students that are losing financial aid in the first term are unlikely to continue into the second term. This is an insight that I can get from the system that I can then use as a basis to make a recommendation to my boss and say that we should increase our financial aid for first term students that are going into second term to make sure that we retain those students. In addition, I can bring in external data. So not only can I analyze and visualize the data that IT has prepared for me, but I can also bring in my own spreadsheets and my own data into this analysis. For example, I can bring in a spreadsheet that has the planned enrollment or the forecasted enrollment on my desktop into this particular report and look at the planned enrollment versus the actual enrollment. It's something that I can do without help from IT. So thus far what we've done is we understood what happened, we've driven some insight from the data, and we may think we're ready to go to our boss and say that we need to try to retain more students by providing additional financial aid. That could be a costly investment. It's an investment in money and effort that we would have to make to try to retain a certain number of students. However, with a large investment in information technology and all these different data points that we're collecting, Decision makers today are expected to make decisions that are smarter and more informed, and not just that are knee-jerk or based on experience. This is where SPSS and predictive analytics comes in. Now, if I could take all of these thousands of students and analyze the many variables that we collect about them, so not only things like gender and ethnicity and major, but all the other things, their GPA, whether they live on campus, off campus, whether they were recruited as an athlete, do they participate in any clubs, do they belong to a fraternity or a sorority, all of these variables come into play. When SPSS analyzes this data, it will group students into 3 clusters if we so choose, and that is of how high, medium, and low propensity to not enroll from first into second term. In this particular part of the capability, with the ad hoc capability, as an analyst, I'm able to analyze 2 or 3 different types of dimensions. I may decide to look at financial aid, ethnicity, and major, and then come up with some kind of conclusion that financial aid correlates to students not enrolling into second term. However, SPSS will either confirm that thesis, or maybe find something a lot more interesting. And in this case, it will actually predict the profile of the student that's likely to drop out. And it may turn out that it's something completely different that I never even thought of. So all of that is descriptive analytics, and then we can move into predictive analytics, and that is predicting how likely specific students are to drop out from first into second term. So not only can SPSS predict, or rather describe the profile of the student that is likely to drop out, but also tell me which students are highly likely to drop out. Now let's take that one step even further and say not only are these the students that are likely to drop out, but this is the next best action. This is what you should do to retain these students. There are 10 or 20 different things that you could do at various costs. This is the one that's most likely to work. So SPSS can actually provide that recommendation. Now that we're ready to start making decisions, wouldn't it be nice if we can analyze the financial impact of those decisions? So we can never hope to retain all of the students, but we may decide that it makes sense to retain 30 or 40 or 50% of those students. What is the cost of trying to retain those students using the various tactics that are available? This is where TM1 and what if analysis comes in. I can build various models that tell me what it's going to cost to retain students under various scenarios. Now that I'm ready to make my decision, there's one final piece of this puzzle, and that is collaboration. So nothing happens in a vacuum, and the Business Analytics Suite provides a full breadth of capability for users to collaborate. One additional point is that we've looked at our insight across all time horizons. So not only do we see what happened in the past, primarily with Cognos, and what's happening currently, and driven some insights from the data, but using SPSS, we predicted what's likely to happen in the future, and what are some of the alternatives that are available to us. And finally, using TM1, we're able to project our decisions in the future and understand the impact they will have in various areas, such as staffing for instructors. Do we have enough classroom space? All of this is available on one platform. There's one place where users go to access all of these capabilities, and that is our unified workspace. So there's one place where users going to access both the business intelligence, the predictive, and the what if capabilities, and also to collaborate using any device. So it's BYOD, bring your own device, whether that is a desktop browser, whether it's a mobile device, a smartphone, an iPad or a tablet, or through Microsoft Office. All of those devices have the capabilities to access all of these capabilities. And finally, all of this resides on a single metadata layer. And at the end, it's that single metadata layer that gives that one single version of the truth. It's one point to administer all of these data inputs. And now let's move into the product demonstration. What I have in front of me right now is an active report. This is an offline dashboard that can be pushed out to users without them having to do anything on the system. So these can be distributed via email, they can be pushed out to their mobile device, or users can run them as they please. They are completely self-sufficient and self-contained. So I can interact with this data without running any queries. It's a self-sufficient file. So as I click on these bubbles, you can see that the charts on the right will update. The chart that I'm looking on the left is retention by career. So the different bubbles are the different careers. The big bubble is undergraduate, and the size of the bubble gives me the student count. So the larger the bubble, the more students that I have. And obviously my undergraduate student cohort is the largest, followed by the graduate, and then I have my law school and some other schools here. So as I click on these bubbles, you will see the charts update. And for my undergraduate population, I can see that the in-state, or rather the out-of-state students have a slightly better GPA. I can also see how I'm doing retaining these students. So on average, I'm retaining 75% of my undergraduate students. And I can interact with these filters, so I can look at males versus females. Males, I'm retaining better than females. I can also look at this by ethnicity, and you will notice that as I click on these checkboxes, all of the charts update. So it's highly interactive and it's instantaneous because no queries are being generated. Let's take a look at the tuition summary. Here I can understand the cost of the different programs. So as I click on the undergraduate slice of this pie, you will see that the other charts update. And now as I hover on the right, I can get an understanding of how much it costs to attain these different programs. So agriculture and life sciences cost so much compared to architecture, art, and planning, which is slightly higher. Below the pie chart, I can understand the program financial aid average, and I can see that continuing education, not surprisingly, is costing me less financial aid. That's pretty typical. I can also see the financial aid demographics. The larger the bubble, the more money it goes to that particular demographic. And the final tab that I have here is Advancement Overview. This is where I can start to get an understanding about my donations. The size of the bubble here gives me the amount by recipient per year. The largest bubbles are my health sciences bubble, which is not surprising. So as I click on these bubbles, you'll see the other charts will update as well. So as I click on my health sciences, which is my largest bubble, meaning I get more donations from health sciences than anywhere else, you will see the other charts have updated. The chart that's immediately to its right tells me the gift source breakdown. It's a waterfall type chart, and I can see that more funds come from the foundations than anywhere else. This particular chart tells us where the donations are going. So they're mostly purposed into research, but we can see that in the previous year that has slightly changed. I can also see the donations by size of gift, and I can see that for health sciences, large gifts tend to be the norm. This is an example of a high-level dashboard. If I decide to get a further look into the data, I can connect to it live. This is a Cognos workspace, and it's the kind of workspace that we described in our PowerPoint presentation. This particular workspace tells a story about our retention. So how are we doing retaining students at our university? The first particular chart gives us admission type by college. One thing that's obvious here is that the School of Technology is our largest college. And as I right-click anywhere on this workspace, I get various different options. So I can drill down on the chart, I can go to related reports, I can apply various filters, I can get the data lineage. So a simple right-click gives me access to various possibilities. In my particular case, I want to drill down on my School of Technology. It is my largest school, and I want to understand how I'm doing in terms of admitting new students by department within that school. So I'm drilling down into the School of Technology, and here are the departments within the school. So I've gone one level down. Here what I see is that industrial and mechanical technology is my largest department. As I right-click on that, I can drill down into further detail, and I'll get a feeling for how the majors are doing underneath that department in terms of admissions. So I can drill down into whatever the lowest level of detail is, and as you can see, the results that I get are very instantaneous. They are sub-second, and that's really important for speed of thought analysis. My next chart is a pie chart that gives me the split of full-time versus part-time students. The third chart is retention by high school percentile. And what this chart tells me is that students that did well in high school are less likely to leave. So we should focus our attention on recruiting students that did well in high school. As I mentioned earlier, there is a suite of collaboration tools that's available within the IBM Business Intelligence platform. And as I hover on this red triangle, I can see that there are some comments, some annotations here. So somebody has seen this trend and they have annotated it. As I decide to print these charts, these conversations can also be printed out. And so I can keep a track record of all the interaction that occurred around these different data points. The next particular chart gives me the retention variance from first into second term. So this is one of the areas that I'm concerned about. The blue bar gives me the number of students that enrolled in the first term as freshmen. The yellow or orange bar gives me the number of students that enrolled into the second term. And this variance, or this distance between the blue and the orange bar, is the number of students that have not enrolled from the first into the second term. So what I can see is that I've done a pretty good job recruiting additional students after 2005. So we've invested money to recruit new students. However, our second term enrollment hasn't changed. So this is definitely an area that I want to investigate. In addition, you will see this line going up, and that is that variance of first term versus second term enrollees. You will notice that I have this slider bar underneath. So here I can understand the situation as it was at the beginning of the decade. So if I slide the slider bar to the left, I'm filtering on the first 4 years of the decade, and I can see that at the beginning of the decade, I actually narrowed that gap. So I did something right, and then at the end of the decade, that gap has increased again. Applying filters as an end user is simple. So I can delete this slider bar and remove it from my workspace. What that does is that removes the filtering from this particular chart, and now I can see all the years. If I expand the panel on the right, I can bring back another slider filter. Tell Cognos that I want to filter on academic years, and click OK. So with just a couple of clicks, we've reintroduced the slider bar, and now we can again decide to filter on the last 4 years only. And the chart looks exactly as it did before. So that's how simple it is to add filters to our analysis as an end user. One important point to mention is there are breadcrumbs, virtual breadcrumbs in every one of these charts that tell us what exactly we're looking at. And this is really important. If somebody prints this chart, the breadcrumbs give us that context of the data that we're looking at. So on this chart, we're looking at 2005 through 2008 because that is what our filter does. And if we expand this, you will see those breadcrumbs change in real time. As I look at this chart, I may not appreciate how this data is shown. I may not be comfortable with this type of chart. Cognos provides the ability for end users to choose their own visualizations. So not only can I do things like change the color palette, which is pretty elementary, but I can also change the display type. And these are some display types that are recommended. As I click on the More button here, I get this Change Display wizard. So there are hundreds or really thousands of charting capabilities with Cognos, charting combinations. How do I know which ones are right for me? This wizard tells me which visualizations are right given the type of data. So bubble chart is recommended because of these reasons. In my case, I actually want to look at this as a crosstab because that's how I'm comfortable viewing this data. So we'll click OK, and the data is now displayed as a crosstab. I would prefer to see the years at the top, so I will flip the rows and the columns. Furthermore, I don't like how these columns are named, so I'll simply right-click and I'll call this first term enrollment. Second, I will rename the other column and call this second term enrollment. One final thing I want to do here, I don't really like the way this variance is calculated. I would rather see a percentage of students that I'm losing rather than a raw number. So I'll go ahead and delete the variance. Simply right click and delete. Select these two rows, right click and build a calculation. It's building a calculation doesn't require the user to enter anything. We simply right-click, and the types of calculations that make sense are displayed for the end user. So we'll go ahead and find the difference between the two terms, and we can see that we're losing so many students from first to second term over the year. So we can see that jump from 05 into 06, and it stayed at above 30%. So that is the area that concerned me. At this point, I can choose to change this back into a graphical format. So here's a line chart. I can add more years to my line chart, so this slider filter still applies to the same visualization. So that is how simple it is for me to manipulate and get the data that's useful to me. On the lower right, I have a bubble chart that gives me a percentage of students that are not retained by gender and campus. One thing that visually stands out, and this is why visualizations are important, is that undergraduate students, which are female, which is the blue color, are the ones that have the largest bubble. So I'm having the largest problem retaining students that are females and that are undergraduate, according to this chart. Let's take a look at some filters here. So let's take a look at in-state tuition, rather in-state students. So as I click apply, now this bubble has actually grown. What this tells me is that I have more trouble retaining female students which are undergraduate and that are in-state. So now I have more information about the kinds of students that I'm losing from first term into second term. And I have one more selector here on the right. Let's take a look at some ethnicity. So let's just pick one ethnicity and see how that particular ethnicity is doing in terms of retention. That bubble is now even more pronounced. So now what I know is that female students that are undergraduate, that are in-state, and that are Hispanic are most likely to leave. So this is insight that visualization and a robust business intelligence tool can provide me. I can take this analysis and this insight, take it to my boss, and recommend that we do something, that we apply a particular program to Hispanic students, which are female, which are undergraduate, and which are in-state, thinking that that will solve our retention problem most effectively. That may or may not be the case. What we've done so far is we've analyzed just a few variables, but there's so many other things that we collect and that we should know about our students, not only whether they're in-state or out of state, whether they're undergraduate or their gender and ethnicity, but also things like, are they on campus or do they live off campus? Do they participate in any clubs? What is their GPA? Which high school do they come from? There's an endless array of variables that we gather and that a human cannot possibly all analyze at the same time. Here's where predictive analytics comes in. So SPSS has actually analyzed all of our data, the same data that we just looked at. And what we have found is that housing is actually the #1 predictor. So if we decide to spend a lot of financial aid on Hispanic students, financial aid is actually pretty far down on this list. So scholarships is pretty far down. And minorities are also pretty far down. So if we focused on a particular ethnicity, we would have missed the reason why students are dropping out. So let's go back to our top predictors. We have housing and club memberships as the top two. What this tells us is that the level of engagement that a student has on campus is their #1 factor of whether they will stay first into second term. And this actually makes sense. It makes sense that a student comes into a university not knowing anybody. If that student is not involved on campus, they will feel lonely, homesick, and they're more likely to go to another school. So while intuitively that makes sense, by looking at the data, we may have come to a totally different conclusion. The third predictor is cumulative GPA followed by infirmary visits. So we might be having some health issues as well that are connected to students leaving. So those are the top factors that predict whether students are leaving. Thus far, we've looked at descriptive analytics. We've understood what is happening and why students are leaving, why students are dropping out. Now let's take this a step further and cluster these students. So SPSS has done that for us as well. It's clustered the students into 3 risk levels: high risk to leave, low risk to leave, and medium risk to leave within both the first and second semesters. Even one step further, SPSS has actually given us the likelihood of students to leave on a per student basis. So as I click on this blue slice of the pie, Cognos displays a list of students that are at high risk of leaving in the first semester. These are in-body prompts, so I can change the prompts on this report. So I can look at maybe medium risk students. I may decide that it's more worth keeping students that are at medium risk because they may be easier to retain. So it's up to me what I want to do with this information, but these are the students that are at high risk of leaving. And I have some demographic and some information about them. So I have their student ID, I have their name, and some other things about them. Specifically, some of the things that we've tried to do to retain them. And the yellow highlight tells me that we've tried to do at least one thing to retain that particular student. Also, by looking at this report, we'll notice that these students have blue underlines under their student ID. As a browser user, I know that if I point, I can click on that and get more information. So let's go ahead and click on Dawn Murphy here. Now we'll get even more information about this particular student. We also have demographic information, marital status, where they live, are they a college athlete, etc. So additional information about the particular student. And very importantly, we also have the dropout confidence rate that SPSS has given us. One type of functionality that I'd like to point out here is that I can create user-driven alerts. So as a student advisor, as an administrator at the university, I don't have the time to go back and monitor how the student is doing on a daily, weekly, or monthly basis. So what I can do is I can create an alert on this particular student. I can right-click on their dropout confidence rate, and I can do this with any numeric field and create a new watch rule. So I will say if the dropout confidence ever decreases, so if it goes lower to what it is, meaning we've done something that works, I want to be notified because I want to see what we did that's working with this student. So I set up my alert for a dropout confidence being lower than 78% for this context, so for this particular student. And I want Cognos to send a report to me via email, to publish a news item on my portal page, and also to send a notification. And I can modify these options. I can type the email in a manner that I want to. I can decide what to do with the report. Do I want that to be emailed to me, or do I need to log in to get it? So there's some additional options that I will not get into at this point. So in addition to being presented with the student details here, Cognos via SPSS is telling me that the most significant dropout predictor here is housing, and that student lives off campus. So at any given time, there are multiple things that we can do to retain this student. And what Cognos, or rather what SPSS recommends that we do, or rather what the next best action is, and the intervention that's most likely to be effective is a buddy program twice a week. So this is the most likely to be effective program that we can apply for this particular student to keep the student from dropping out from the first into the second term. And with that, we've gone from looking at data at a very high level for the university as a whole on a historical basis or on a current basis into what's happening or what's likely to happen in the future, and further applying that to individual students and applying programs or tactics that are most likely to be successful in the future. And that is the value of the IBM Business Analytics platform, being able to provide insight and actionable information across all time horizons and provide insight that can lead into smarter decisions, which then create better outcomes for organizations.